Today we're going to do some more examples using the mean value theorem. If you watched my other video, it explained the process of doing the mean value theorem. So if you actually haven't watched that video yet, you may want to do that because it's going to be explaining the theory, the step-by-step process. This video is just going to be doing some more examples of the mean value theorem. Okay, so I have 3 examples up, some pretty simple ones, one semi-difficult one, and 2 easy problems. Okay, so I kind of go against normal step-by-step procedure. I usually go ahead and find the first derivative of the original equation. This is a rational function, so we're going to go ahead and use the quotient rule. Got x plus 1, x prime minus x plus 1 prime x divided by, you know what, this is getting too big. Let's go ahead and go back. Gotta make some room for ourselves. X plus 1, x prime minus x plus 1 prime x divided by x plus 1 squared. X prime, that's just 1. That's just going to be just x. That's just going to be x plus 1 because the 1 is just going to go ahead and distribute into there. The derivative of this right here, that's 0. That's just 1. 1 times x, which is just going to be x. And we're going to be left with x plus 1 squared. These x's are going to cancel, and we're just going to be left up with f prime of x of the original function is just going to be 1 over x plus 1 squared. That's going to be your f prime right there. So I'm actually, to save space, because I know this is pretty big, I'm going to go ahead and erase my steps. So you may want to stop and pause and get the information of how I got that. Okay, so now we have our first derivative. Now we're going to use the mean value theorem to find our approximation. So remember, this is your a, this is your b, the original function, so you have 2 over 2 plus, I apologize, 2 over 2 plus 1. Okay, so then plug the a in there, you have 0 plus 1, all divided by 2 minus 0. That's just going to be equal to 2/3 minus, that's just going to be 0 divided by 1. You can forget about that because that's not going to equal anything. So now you just have 2/3 over 2. So now that you have this equation, you're going to set it equal to your f prime. So now you have 1 over x plus 1 squared equals to 2/3 divided by 2. And we're solving. So when we plug this in the calculator, this is actually 1 divided by 3. So then we go ahead and set it equal to our derivative. We can forget about these 1's, and then it's actually x plus 1 squared equal to 3. We can take the rad of both sides, and now we have x plus 1 equal to rad over 3, or radical 3, and then subtract 1, so now x is equal to radical 3 minus 1. And that's the answer to this equation. Now let's do a really simple one real quick. The derivative of that, we know, is just going to equal 2x. Simple enough. Then you do your mean value theorem. That's your b, that's your a. That's going to be 3 squared minus 2 squared divided by 3 minus 2. 3 squared, 3 times 3, that's just going to equal to 9 minus 4, 1, which is just 5 over 1, which is just 5. Then we set it equal to our derivative. Divide by both sides. And now x is equal to 5 divided by 2. And that's the answer for our original equation using the mean value theorem. So by using the mean value theorem, we figure out 5 divided by 2, that's still within the intervals. Remember, this is the most important thing using the mean value theorems. It's not always going to work. Whenever we do this, if the answer to your x is actually beyond or before the interval that you've been given, remember, you want to reject that one and keep what is within the interval.
Otherwise, it's not going to work. Just like this problem, this is within the interval that we've been giving, 0 and 2. If you plug this into your calculator, it should be between 0 and 2. It should still be a positive number. So if you still don't understand how this was done, go back and watch the video, and you'll be able to understand how we got this process. Remember, this is your mean value theorem function. That's how we did all this mess and set it equal to the original derivative. So go watch my videos, and I will see you later.